Yeah. So yesterday we have seen about this topics. I think my screen is visible, right?
Yes,
To
sir.
respond with topics.
Yes, sir.
Okay. So yesterday we have seen this BCD. Okay. So we have explained what is BCD. It is a binary coded decimal. It is a 8421 code of the decimal values. So 0 to 9. Okay. And we have spoken about is excess 3. So addition of 3 to the BCD values. Okay, addition of 3 to the BCD will get the excess 3. And the 2421 and A4 minus 21 codes are other kinds of codes here. Okay. So we have done some problems related to XS3 also. Now coming to this gray codes, already explained the concept of gray codes. So in gray codes, the difference between the changes between the corresponding or the adjacent values will be equal to 1. Okay, there is only change in the 1-bit position. So for the adjacent values, so adjacent codes will be having the adjacent codes here. Those adjacent codes will be differed by 1-bit position only. So whereas coming to the simplification, so simplification process will be very easy. So when we have these gray codes, okay. So we'll come further. So in the coming units, what will come across here is, so these every minimization techniques use this gray codes here. Okay, you can check here the difference between this one and this one is differed by, it is differed by 1-bit position, and this one and this one is differed by 1-bit position, and this one and this one is differed by 1-bit position. So you may get confused regarding this how this sequences happen, but I'll let you know the conversion process of binary to gray code conversion and gray code to binary code conversion. So how to convert the binary to gray codes and gray codes to the binary codes. Okay. So before going to the conversion process, I'll explain the one function called as exclusive function. So you have to know about this exclusive function. One minute. Right. Uh, exclusive OR function. So this is one of the functions of logic gates. But so our next topics will be the logic gates. So you'll know what is meaning of logic gate, what are their functions. So before going to that, we need this function for this operation. Okay, so I'm explaining this exclusive OR function. Okay, so if I'm taking any two inputs, I'll give the two inputs as x and y. Okay, and if I give some XOR operation as z, okay, XOR operation as z. So I'll let you know the exclusive function. What will be the output? Z will be the output here. Okay, so it is XOR operation of x and y. So z is XOR operation of. So z is equal to x XOR. I am writing it as x XOR of y. Okay, so this is the output of z here. So we'll be using some symbol for XOR operation also. I'll let you know. Okay, so meanwhile we'll check what is the function of exclusive OR gate or exclusive OR function. So if I take two inputs here, so only in binary. Okay, 0 0 is the first one, and 0 1 will be the second one. This is second input. Okay, and 1 0 1. Okay, so that is XOR operation. So here when we check about is XOR operation, so the XOR operation between two identical inputs will be equal to 0. The output of XOR. Okay, so if Z is equal to 0 for two identical inputs, when the inputs are not identical, okay, so if X and Y are equal, so identical, so then Z will be equal to 0. Okay, and if X and Y are different, x and y values are different, z will be equal to 1. Okay, so this is one of the method to explain the XOR function. So for this gray code to binary code conversion and binary to gray code conversion, this is fine. Okay, so here x and y are equal to 0, 0, hence z will be equal to 0. Here x is equal to 0 and y is equal to 1, and z will be equal to 1. Okay, and here x is equal to 1 and y is equal to 0, hence z is equal to 1. And x is equal to 1 and y is equal to 1, both are equal, hence z is equal to 0. So this is the XOR function. So XOR function is, this is the XOR function here. Okay, so where identical inputs will get a 0 output, and unidentical inputs or unequal inputs will get a 1 output. Okay, you got the function right? You're clear? Yeah. Okay. Fine. So now what we'll see the binary to gray code conversion. So we'll see how the method of binary to gray code conversion. So please follow, because these each and every topic is important for the coming classes or future classes. All your 4 to 5 units, you should know all these concepts. Binary to gray code conversion. So I'll give some binary codes. We'll start with a simple problem. Okay, we'll start with a simple problem. I'll give some binary code here. This is the binary code. I had to convert this into the equivalent gray code. I had to convert this into the equivalent gray code. Okay. So method will be like this. The first bit is same. So this is, if you consider this as binary, okay, and this as the gray code here. So in gray code and binary code, the most significant bit. So this is called as the most significant bit, and this is called as the least significant bit. Okay, so that will be the most significant bit, and this will be the least significant bit. Okay, so this is MSB, so which is the most significant bit, and this is LSB, which is called as least significant bit. Okay, and coming to this binary and gray codes, the first bits are the same. The MSB bits are the same here. For binary to gray or gray to binary, the MSB bit will be the same here. Okay, and coming to the next bit, so I need to know this bit here. Okay, so exclude-OR operation, the symbol will be like this. This is the symbol for exclude-OR operation. So plus with a circle. So that is a symbol for the exclude-OR operation. Okay, now what I have to do here is, so how to convert this binary to gray, I need to take the exclude-OR of operation of these two. Okay, so 1 and 0, and exclude-OR operation of this one and this one, and exclude-OR operation of this one and this one, XOR operation of this one and this one, so XOR operation of this two, XOR operation of this two, so XOR operation of these two. Okay, and outputs will be like this. So 1 exclude-OR of 0. So what is 1 exclude-OR of 0? So from this, 1 exclude-OR of 0 is 1. So when we have two identical inputs, I'll get a 1 output. And a 0 exclude-OR of 1, it is a 1. Okay, and 1 exclude-OR of 1, it is 0. Okay, and 1 exclude-OR of 1, it is again 0. And 1 exclude-OR of 1, it is again 1 here. Okay, 0 exclude-OR of 1, it is again 1. And 1 exclude-OR of 1, it is again 0. So this will be the gray code here. The gray code is 1 1 1 0 0 1 1 0. So for this binary code, okay, so for this binary code, like this binary code is 1 0 1 1 0 1 1 0 1 1 1. Yeah, 1 0 1 1 0 1 1 here. So binary code is this one, and this is the corresponding gray code. So this is how we convert this binary to gray code. Okay, so let you know. So we'll take one example here. So in your table also. So we'll take one example here. I'll take the value of this is the binary code. So 1011. Okay, so 1011. So this is binary. Okay, gray code. So the MSB will be the same here. Okay, and what I had to do, I had to perform the exclusive operation of these 2 bits here. Okay, so what is the value I'll get here? So 1 excluder of 0, it is 1, and 0 excluder of 1, it is again 1. Okay, and so 1 excluder of 1, it is again 0. So 1110. Did we get this? 1011 key, right? Yeah. So 1011 key. This is the binary code, and this is the gray code. Okay. You can check with this also. 15. So 15. So binary code is 1111. Okay. And this is the binary code, and corresponding, I need the gray code here. Okay. So here MSB will be the same. So 1, and the exclusive operation of the adjacent bits here. So 11, it is a 0, and here these 2 bits will give a result. It's a 0, and these 2 bits, it gives a 0. Okay, so this is how we convert this binary to gray code here. Okay, so any doubts? Any doubts here?
No, sir.
No, sir.
So anyone? Any doubts?
No, sir.
సార్
Yeah.
బైనరీ కోడ్లో స్టార్టింగ్ వన్ అలానే పెట్టి గ్రే కోడ్లో స్టార్టింగ్ అదే తీసుకోవాలా సార్ మనము?
So binary code, in binary code, the starting MSB value will be equal to this. Gray code also, the values will be equal. MSBs are equal.
ఓకే ఓకే
Okay. So we'll not change the first MSB. మనం first change him.
ఎస్ సార్.
Okay. So we'll only change the remaining things. Okay. Clear? So this will be a symbol here. So this is binary to gray code conversion. You have to know this. This is the binary to gray code conversion. Okay. The first bit will be the same here. Okay. The first bit is same. Okay. And next bits will be like this. It's quite difficult to draw like this. Okay. But I'll use this annotation. Right. So exclusion of these 2. So first bit is same as it is. Okay, and the next bit is second bit is exclusion of these 2. That is 101, and exclusion of these 2. So 01, it is a 1, and exclusion of these 2. So 11, it is a 0, and exclusion of these 2. So 11, it is again a 0, and exclusion of these 2. So 10, it is again 1, and exclusion of these 2, it is equal to 01, it's a 1, and 11, it is a 0. Okay, you got the procedure right?
Yes, sir.
So if you are clear, I'll give the problem. I'll give the problem. Right, we'll solve 3 problems here. Okay, next we'll go for grade 2 binary code conversions. Clear, everyone?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Hope you are clear, and I'll give the problems. So convert the following to gray code. This is the first one. This is the second one. So we have to do this in a matter of minutes as of now, but a matter of seconds to general gate. Right, so 1246 in hexadecimal. Okay. So what is the first step we have to do in each and every problem here? So what is the first step? So what is the first step we have to do? So we are given some
Convert to decimal.
we are given some octal value, the decimal value. Afterwards, we are given it to the hexadecimal value. So we have to convert them into the binary values. So we have to only two possibilities here: binary to gray code and gray to binary and So now I want these values to be converted into gray code. So first of all, we have to convert them into binary. Okay. So each and everyone has some method here. Okay. So no need of going for we know the conversion from binary to octal to binary. So I discussed about octal to binary. So octal to binary conversions will be like this. So each and every decimal is given a group of 3 binary bits. So 2 ante it is like 0, 1, 0. So 3 ante I can write it as 0, 1, 1. So 4 is nothing but so 100. So 5 is 101. So octal to binary conversion. So that will be the binary value. Okay. So you'll get the binary values, octal to binary conversion. We have seen the process. I want you to maintain the notes because when you get the conversions, definitely you'll get confused. So definitely we could have solved 1 or 2 problems in Tamu. Just you can refer that and you have to practice them more and more. Okay. And second one is decimal here. So decimal to binary conversion. So we can divide it by 2. Okay. So divide them by 2. So we'll get the binary value. Okay. And next one is hexadecimal. Sorry, I know that that has been disconnected, but once it is disconnected, it will take on 1 or 2 minutes for me. Just you have to bear with me. Right. So this is the problem. Right. These are the problems. To solve these problems, so within 15 minutes.
Screen is not visible, sir.
Yeah. 1 minute. So I think recording is going on. Yeah, recording is fine. I have to share the screen. Clear?
Yes,
Visible,
sir.
right? Yeah. So do these problems. So I'll be taking a 15 minutes break. I'll have my lunch and come. So meanwhile, you solve these problems. I'll be back. So 1 minute. I'll share. So only 4 people. 1, 2, 3, 4, 5, 6. Answers are 4, 6, 0, 1, 0, 0, 1, 0, 0. Okay. So 1, 0, 1. 0, 1, 1, 0, 1. Fine. Double 1, 0, double 1, 0, 1, 1. 0. Yeah, correct. So if you want to include zeros, you can include zeros also. So it doesn't affect any answers here. Okay, so most of the things are correct. So if you want, if you don't want any confusions, you can include those zeros, so which are there also. Okay. Yeah, Manoj, yeah, corrected that. Prati, third one, 0, 0. The other one, 0, 1. You are correct. Excuse me. Yeah. So few answers are correct. But you're on the way. Most of the answers are correct. Okay. So I'll let you know once again. We'll see. Okay. So that I'll understand that clearly. 2, 3, 4, 5. And so the binary values is like, so sometimes I may take zeros, switch out to the left, or I may leave that. But so let's take, because you may get confused. 0, 1. So this is the binary one. Okay. And you need the gray codes for this. So 1 minute. Right. So MS will be the same here. Okay. And the next one, 0 excludure of 1. It's a 1. And 1 excludure of 0. It's a 1. And 0 excludure of 0. 0. Okay. And 0 excludure of 1. 1. 1 excludure of 1. It's a 0. And 1 excludure of 1. it's a 0, and 0 exclusion of 0, it's a 0. Sorry. 1 exclusion is a 0. 1 exclusion of 0, it's a 1. 0 exclusion of 0, 0. 0 exclusion of 1, 1. And 1 exclusion of 0, it's a 1. Okay. And 0 exclusion of 1, it's a 1. Okay, so this is gray code here. Okay, so 0 11 0 1 0 0 1, so 1 0 1 1. Okay, so it's better you take this MSBs also, like so if it is like zeros, zeros could include JSS code because it'll get confused. So include those zeros also. Okay, so the main task lies with the conversion of octal to binary, right? So most of them are correct, but I want other people to note it down. Okay, so this is for the answers here. Okay, next one is 77710. So if I convert it into gray code as like a binary, I have to divide it by 2. Okay, so the answer I'll get here is 11 00 00 1 00 1. Okay, so 11 00 00 1 00 1. So this is the binary code here. Okay, so after conversion, so go with the division process. You know the division process, right? So go with the division process. Like so, divide them, and you'll get the answers. Okay, so there is a binary code for this. So after getting this binary code, convert them into the gray code. This is binary. And coming to gray code, so MSB is the same. So to perform exclusion operation of adjacent bits here. Right. So 1 is the same, and 1 1 it is a 0, and 1 0 it is 1, 0 0 it is 0, and 0 0 it is 0, and 0 0 it is 0, 0 1 it is 1, 1 0 it is 1, and 0 0 it is 0, and 0 1 it is 1. So this is gray code, right? So gray code for this one is 1 0 1 0 0 1 1 0 1. Okay, and the next one is 1 2 4 6. 1 2 4 6 hexadecimal. So we'll get these values like 0 because it is what we have to write here is, so each and every decimal is represented in a 4-bit binary code. 0 1. So for 1 it is 0 0 0 1 0 0 1 0. So 4 it is 0 1 0 0, and 6 it is 0 1 1 0. Right, this is binary. And coming to gray code, so MSB remains the same. And coming to LSB, it's 0 0, it's a 0, 0 0, it's a 0, 0 1 it's a 1. So 1 0 1. So 0 0 0 0 1 1. So 1 0 1. So 0 0 0 0 1 1. So 1 0. Sorry, 1 0 1 0 0 0 0 0 it's a 0 and a 0 1 it's 1 1 1 it's a 0. So 1 0 it's a 1. Right? So these are the answers. 000 or 110 11 Okay, so this is the gray code. Okay, check your answers. Okay, so this is how we convert this binary to gray code. So binary code to equivalent gray code. So we will convert this. Now we'll see the conversion of gray to binary. Okay, so we'll see the conversion of gray code to binary code. Right? So everyone is clear, right? Everyone is clear with this binary to gray code conversion.
Yes, sir.
So what I mean, you are clear. Okay? So you understood this, and there is a less probability of doing the mistakes. Okay, so understood ante na దృష్టిలో అయితే మీనింగ్ అది. సో మీరు మిస్టేక్స్ తక్కువ చేస్తారు అనే ఉద్దేశం అన్నమాట. Okay, so next if you are given the same problem after 1 week, you should be able to do this because you have to register your procedure, your method, the way of doing the method in your minds. Okay, right. So next we'll see the gray to binary code conversion. You can also implement the same techniques but in a different way. Okay, so we'll take any code here. Right. So we'll take any code like, so 9 ki gray code తీసుకుందాము. So 1101. So 1101 is the gray code of 9. So I need the binary equivalent of this. So binary equivalent, if I need the binary equivalent, so what I need first here is, so first MSB is the same. Okay, and you have to perform exclusive operation of this bit and this bit. So diagonal wise. So not the first one, the second one. And the result is this one. So 1 exclusive of 1, it is equal to 0. And this is done XOR operation with this one. So 0 exclusive of 0, it is 0. And this is done exclusive of operation with this one. So 0 exclusive of 1, it is a 1. So it is equal to 1001. So this is the binary code, equivalent binary code for the given gray code here. Okay, I'll explain one more time. So take the value of 11. 11 ki gray code enti kada. So 1110. 110. So this is the gray code. Okay, binary code ki the first one is same, and I have to perform exclusive operation diagonally. So this value and this value. Okay, so we'll give the result of the next bit. So 1 exclusive of 0, it is 0, and this exclusive of operation, this 0 and this 1. Okay, so 0 exclusive of 1, it's a 1, and here we get a 1 here. So this 1 exclusive of this 0 is equal to 1. So 1011. Okay, so gray code 1110 and the binary code is 1011. Okay, so to perform exclusive operation diagonally. So take one more value. So 0100, so which is gray code for binary 7. Okay, MSB is the same, and so coming to this other things, so this 0 and this one. Okay, so 0 exclusive of 1 it's a 1. So 1 exclusive of 0, it's a 1, and 1 exclusive of 0, it's a 1. So this is binary. Got it? Clear? Yeah. Okay. So please respond to audio if I'm not checking your screen, because I'll not check the chat box, because when I'm sharing the screen I may not be able to check the chat box. Okay. So now we'll see the example. Okay, this is the simpler one. Now we'll see the example, and in exam also you have to write in this way. Okay. So gray code to binary code conversion. For example, if I take it for 6, so it is 0 1 1. So this is the gray code, and the binary code will be like this. So MSB is the same, 0, and this is, we have to put the exclusive or symbol here. So this 0 exclusive of 1, and down arrow. So 0 1, it's a 1. So 1 exclusive of 1, it's a 0. 0 exclusive of, sorry, 1 exclusive of 1, it's a 0, 0. Okay. So 0 exclusive of 1, it is a 1. Okay. Yeah, 0 1 1 1, the corresponding binary code is 0 1 0 1. Okay. So take down the problem. So convert the following gray code to binary code. So gray code is a gray code. I need the corresponding binary code. This one will be the same. I have to perform exclusive operation of these two, and result will be here, likewise. Yeah, the answer is 1 1 0 1 1 0 1 1 0 1 0 1 1 1 0 0. Yeah, correct. Okay, so but the method you have to mention here is like you have to mention the exclusive or symbol here, and you mention that method, right? So this is a grade 2 binary code conversion. Okay, if you are given any kind of if the problem is like if you are given any kind of codes also, so gray codes ante anni 1 zeros lo istaru meeku. Okay, so binary ante, so convert them to binary and next to the gray codes. Okay, this is how we have to do. So we have to understand the method like this. So what are the problems? So there is only two possibilities here: binary to gray and gray to binary conversions. So if you are given some decimal or hexadecimal, convert them to binary first. Okay. So if you know the binary, next we can go for the gray code. In case of gray code to binary conversion, you'll be already given the binary codes. Okay, that convert that into the gray code. Okay, so there's a set of problems we'll come across. So when we discuss about this binary codes and gray codes here. Okay, and coming to your syllabus. So wait, I'll show you. Right, so we are done with this XS3 code and gray code. Okay, so now I'll let you know this binary code classification. So what are the classification of the binary codes? Okay, and tomorrow I'll let you know what is ASCII code also. Okay, so now we'll see this binary code classification and wind up the class. Right? So Chudama, right, Chudama?
Tomorrow, sir.
Yeah, I know I'll get a tomorrow answer first. No problem. We'll stop for
Tomorrow,
today.
sir.
Yeah, so no problem. We'll see tomorrow. So by what time you'll be ready in the morning? Actually, the schedule is quite hectic for me. So what is your convenient timing in the morning sessions?
SS class calling sir.
Huh?
SS class calling.
I'm not talking about timetable. So timetable is leave the timetable. So I am asking about which time you are convenient. So morning enter lestar meeru.
Morning.
I want to take the class at 7:30 in the morning every day. Yeah.
Okay, sir.
So 7:30 to morning hours will be very fresh and it will be very good also. Like 7:30 to 9 or 8:30 or 9:30 also. So maths class will be there, no? At 8:30. Okay. So every day 8:30 maths class untunda? Okay.
Yes, sir.
But I need at least 1.5 hours every day, minimum of 1.5 hours, because I'll be wasting a lot of time in middle because I don't want to take the classes continuously. I just want to give some breaks in between also. Okay. So 9 will be fine. So maths class will be there, no? So 8:30 to 9:10.
8:30.
So I'll let you know. I'll talk with so Ravi sir and I'll let you know the timings also. And so this is a 9 and convenient timing, like kunte milese timing adi.
Yes, sir.
Sirisha and Suprati.
Convenient times.
Convenient time.
Convenient time. Convenient.
Okay. So 9 is your convenient time because you get up at 9 o'clock. So 7 to 8:30, morning 7 to 8:30. So for me, this is the better timing, 7 to 8:30.
7 to 8:30.
Yes, sir. 8:30 maths class ఉంటుంది కాబట్టి so 7 to 8:30 it's fine.
Morning.
Yeah. Let me know. CR, let me know by tomorrow. If your convenient timing is 7 to 8:30, then we'll just go for that.
Okay.
No, morning sessions will be really good. Taking class in the morning sessions, there will be no disturbance. Okay, and your mind will be very fresh. So you can take the class in a better way. Okay, I'll let you know. So tomorrow also we'll continue with the same timing, like around afternoon. Within 1 or 2 days, I'll let you know the timings. Okay. Right. So have a nice day, and so see you tomorrow. Yeah, drop your attendance there. And I'll send the recordings. Yeah, I'll send the recordings. So within 1 or 2 days, because I'm seriously నాకు ఆ మెయిల్ లో చాలా రికార్డింగ్స్ ఉన్నాయి, థర్డ్ ఇయర్ ఉన్నాయి, సెకండ్ ఇయర్ ఉన్నాయి, ఫైనల్ ఇయర్ ఉన్నాయి. So I had to sort it out. Okay. So meanwhile, when I find free time, I'll definitely send those recordings. Right. So thank you, and see you tomorrow. Yeah, I shared the 2 recordings talking about the remaining. I think remaining 2. Okay.